Hey, very good morning. Just give me 2 minutes. We are good to start. Yeah. Hi all, a very good morning. So in the part of our yesterday's class, we started looking on to what is VPC, how can we get started with VPC, and we actually created a VPC which has got a public and a private subnet as well. So let's continue to further explore the VPC section. I'll quickly log in into my AWS account. In the meantime, while we log into our AWS account, I'll quickly open up the slide and yeah, we'll recap the session after today. So as we learned about the VPC, VPC usually stands for Virtual Private Cloud. Now, we all know that the cloud providers like Azure, AWS, Rackspace, IBM Software, they're all the public cloud providers. Now, if we start keeping the data on those public clouds, there is a chance that we may put into a default VPC that usually is given whenever we are going to get started, right? So everyone would like to create their own private space, which might be limited to their company's resources or something as such. And that is the where need for the VPC comes into picture. So you can create your own private clouds on these public cloud vendors. So we started learning about what is VPC. So VPC usually consists of following things: IP address ranges, creation of subnets, configuration of the route tables, and the network gateways. So usually whenever we are trying to develop anything in this space of IT, we have two types of application. One is two-tier application or a three-tier application. Now, two-tier application usually consists of web application layer and the database layer, while three-tier application will have web applications in between a middleware or application layer and then the database layer. So usually what happens is we would like to put across the web application in a place where entire world can have the access. That is the reason we call it as web application. So examples would be something like flipkart.com or amazon.in as e-commerce websites, right? So they are actually placed in the public subnets. So now when we are going to get started with VPC, we have a complete control over the creation of subnets. So when I'm going to create a subnet, I'm going to define one of them as a public subnet and second as a private. So all my databases and other things, I'm going to keep it in private so that it is accessible only for me and my company. Whereas I'm going to put across my e-commerce application like web, Amazon or Flipkart towards the end users or public, they can access it across. So I'm going to put it across in the public subnet. And we can enhance the security with the VPC with the help of NACL, that is Network Access Control List, and then the security groups. And we can also have a VPN connection directly between our data center and the AWS cloud VPC, right? So the moment I'm going to go and start creating the VPC, we can leverage the connection of our VPC from my directly on-premise data center using the VPN connection. So if someone wants to connect to the private cloud that has been set up in the AWS from their company, they can straight away directly use VPN, which would be connected to that. So only the administrator who has configured the complete VPC and AWS account will directly have access over the AWS account, but rest of the team who is working inside a company, let's say they have some internal websites that are hosted for their company, they will be actually connecting to that specific portion using this VPN or maybe the direct connect. There are two different ways of connecting to the AWS cloud. And now yesterday we started creating the first VPC, and as I said, we are going to refer to an analogy of land, buildings, or home. So as far as I see, if we understand what is the land, what is the building, how to create houses inside that, that actually gives us a greater insight on what is a VPC. So we are going to completely work out on that specific analogy here. However, before we go there, what are the different types of VPCs I can actually have when we go and get started by creating it? So yesterday we started selecting a Mumbai region in the services. I'll go down to the networking section and then open up the VPC. Okay, so there we see. So there are two ways of getting started with the VPC. You can straight away launch a VPC with the wizard, or you can go and learn the hardest way. So with VPC wizard, it's very easy to get started and creating. So if I just go down to any of these sections, just go ahead and just select. It straight away gives me option to just enter the things across, and then the moment I say create VPC, it is going to create it across. So rather than that, we started learning the hard way of creating our VPC. So I went to each of these sections and then we created our own VPC, then subnets, and the route tables, and then the internet gateways as well. So we actually created each of them manually by going into each of these sections. So as a part of our start wizard, we have four different ways of getting with the creation of VPCs. So first is VPC with the public subnets. So as I just said, we can have public and the private subnets. So now when we try to get the different types of VPCs, we have first with VPC with public subnets, VPC with the public and private subnets, then VPC with public and private subnets plus hardware VPN because we would like to run the data center, and then VPC with private subnets plus hardware VPN. So this is clearly explained here in the start wizard. So here is the first one, that is VPC with single public subnet. So I'll have a public subnet. It need not be single. You can have multiple public subnets in this VPC, and it is actually connected to the internet. And you can have a VPC which has got public subnet and a private subnet. While public is connected to internet, private is just accessible only to the people who have access to this Amazon AWS account. And then we have the public and the private subnet. Public is actually connected towards internet, and the people from the corporate data center can connect to the cloud. This is private cloud, private subnet using the VPN connection. You can also have only private subnets which are directly connected to corporate data center, so nothing is exposed towards the internet. So these are the four different types. So yesterday we started with the creation of VPC. So we had 6 steps in which we were able to actually go ahead and create a VPC. The steps were very simple. I'll just review the steps here. So I have one VPC. I'll quickly go ahead and delete it and then recreate one. So I'll just click on these actions and then say delete. There we go. So referring back to the steps, how do we get created the VPC? I'll also open up one more thing here. Okay, as I said, we are going to refer to this specific analogy of buildings, land, houses, these things, etc. So let me open up this specific image here. So I'm going to open up it in the paint. Okay, so let's understand that we have purchased a specific area of land, maybe 1 acre or 2 acres of land. Let's understand that we have purchased a specific land, and this is a portion of land that we have purchased, which is of maybe example of 1 acre. Now in this, how many houses can I build? Usually depends upon this cider block range. Now when we try to compare the analogy with our VPC here, so in the VPC we are going to give this cider block range. So if you see here, this bar 16 at last, this is going to decide how many IP addresses I'm going to get inside this specific portion of land. Now since we are trying to pick up the availability zone, that is Mumbai in this case, which has got Mumbai region has got 2 availability zones. So I'm going to go ahead and divide this specific portion of land into 2 different parts because of the 2 availability zones. So I have availability zone 1 and availability zone 2 here. So the portion of land is in availability zone 1 and the portion of land is also in the availability zone 2. And I'm going to go ahead and create a VPC with the bar 16 range. That is the highest that we can create. So I'll just go ahead and click on create VPC, and I'm going to give the name AWS training. Cider block range is going to be 10.0.0.0 bar 16, and I'm going to keep it as IPv4 block, and the tenancy I'm going to give it as default, and just say yes. So as we know, if I'm going to take a bar 16, so I'm going to get 65,536 IP addresses. So this is the formula to calculate. 2 power 32 is the base, and whatever range we have given here, I'm going to go ahead and subtract that specific number from 2 power 32. So it is going to give me 2 power 16. So I'm going to get 65,536 IP addresses. So there we go. We have actually created the VPC, and bar 16 is the highest that we can create in the Amazon AWS VPC. Now, once we have created the VPC as per the steps, let's go ahead and verify if the route table is created automatically. I'll just go down to the route tables and check out if there is. There we see there is one route table for the VPC AWS training, and it says main flag as yes, which means each VPC is going to have one main route table. And then let's go back to the subnets. That is the third step. So we started creating the subnets here. So now that we have actually got the land, we also know how many houses can be created on top of this. That is 65,536. Let's go ahead and divide and see how many you want to create. Whether you want to create villas or whether you want to create buildings, it's up to you, right? So I'm going to go ahead and create 2 buildings here. Since we are having 2 availability zones, I'm going to keep this design very simple. So one availability zone will have one subnet in this case. So this is a subnet 1, this is a subnet 2. So I'm just going to go ahead and say create subnet. So I'm going to create this subnet in the AWS training VPC, and then availability zone preference I'm going to pick it as AP South 1A, and then the range is going to be 10.0.1.0 bar 24. So this time I'm going to give the bar 24 as a range for this subnet. So you can decide upon what is the range you want to go with. So basically this bar 24 is going to decide how many IP addresses are going to get in. So that is basically how many houses you can create. I refer it to as. Okay, so I'm going to pick it up as 10.0 to 1.0 bar 24. Now again the base formula is 2 power 32. If I remove the minus 24, which means 2 power 8, so out of this 65,536, I'm trying to create 256, or I'm trying to allocate 256 IP addresses towards this building or this subnet. Similarly, I'm going to create one more subnet here, which is going to have bar 24, and it will be also having 256 IP addresses. So let's go back and quickly create one. So I'll give the name here as 10.0.1.0, and this is the part of AWS training VPC, and this is part of AP South 1A. So this is the name tag that I'm trying to use. I'm just trying to combine these three fields and just yes. I'll quickly create the second one. So again, I'll pick up AWS training VPC preference as A1B now, and it will be 10.0.2.0 bar 24. So again, 256 IP addresses we are going to get this subnet. So there we go. We have created the two subnets. Next, let's go ahead and create an internet gateway. As we all know, this is a private cloud, which means it is completely private. No one else will have access. We will not be able to go outside or anywhere else. So this is private. Now I have to define a door so that people can come inside from that. They can also go outside from that. Right? That is nothing but an internet gateway. So I'm going to go down to the internet gateway. I'm going to go ahead and create a new one. I'll just say AWS training IGW. So currently it is in detached state. So if I go ahead and click on this attach to VPC, it is going to attach it to the VPC, which is available here with the name AWS training. So there we go. We have successfully attached it. Now we have created a internet gateway that is like a prototype for gate, but we have not said this gate will be available towards the availability zone 1 or availability zone 2. That is something that we are going to define in our route tables. So let's go down to the route tables. So as we all know, we have one main route table that gets automatically created whenever the VPC is created. So I'm going to go ahead and create my custom route table. I'm going to name it as my internet RT. RT stands for route table here, the short form, and this is going to be created for AWS training VPC. I'll just say yes, create it. So there we go. Now I'm quickly going to go up, and in the routes, so we are going to define, yes, so this gate prototype is created. Now we are going to define the rules here. Check. So gate prototype is defined. Now we have to define the routes here. So I'm going to say that if this gate is kept across, people will be able to go anywhere, right? So the destination will be, they can go anywhere in the world. And now what will be the target? Target will be basically this internet gateway. That is a gate that which we have created. So using this gate, people in this specific building compound can go anywhere else and travel. So I'm just going to put a cross and save this. And now I'm going to go ahead and tell here which subnet is going to get this direct access towards the public way, like towards the internet, which is the building or which is a subnet that is directly going to get the access. So I'm going to say here edit, and then I'm going to put it as 1.0, that is in the AP South 1A, and then save it. That's why I have now kept this gate inside this specific part of availability zone where the subnet 10.0.1.0 bar 24 exists, right? So this subnet has got direct access towards the internet, and the subnet which is in another availability zone is completely private. So this was the part of activity that we have done yesterday to learn how to get started with the VPC. Now, one important and last thing before we go and proceed with the next part of our class. Here, whenever we are going to create the subnets, you see I'm actually getting only 251 IP addresses, whereas actually as per the calculation of bar 24, we get 256. Remember, the 5 IP addresses are actually reserved by Amazon itself for each subnet, and only 251 IP addresses, or like if you see here in this case of the default VPC which we already have, it has got bar 20 design, so which is usually 4096 IP addresses, but again 5 IP addresses are reserved by Amazon. Now what I'm going to do is quickly navigate down to my EC2 section, and I'm going to launch EC2 instances, one in both the subnet. Now we have created 2 subnets, so this is subnet 1, this is subnet 2. So let's go ahead and create one small house inside this. Maybe I'm going to create one small villa. I'm just checking out if the villa design is going to work out in this, or maybe I can straight away build a building which is going to have 256 houses, something as such, right? So I'm going to create 2 EC2 instances, in this case one inside this 1.0 bar 24 subnet, and second inside this 2.0 bar 24 subnet. So there we go. I'm inside my EC2 section. I'll quickly click on launch instance. So things are going to remain the same. I'm going to pick up the Amazon Linux AMI as a part of a free tier. General purpose T2 micro. The change that comes here is in the step 3. So if you remember, until now we were trying to select the network which was default VPC. Here now I can select my own VPC. So I'm going to say that I'm going to use VPC with the name AWS training, which has got 2 subnets. As per the Mumbai has got 2 availability zones, I have created 2 subnets. So I'm going to select one of them here first, 10.0.1.0. So which is basically a public subnet, which means we will be able to access this EC2 instance from outside the world as well. This EC2 instance can access the internet resources as well. So I'll have to go ahead and enable this public IP address, or else we'll not be able to log in inside this EC2 instance at all. And rest of the things I'll leave it as default and go ahead and say add storage. So root, I will have a root device volume of size 8 GB, which is of type general purpose SSD. Attach it to this EC2 instance, and then add the tags. And then I'm just going to go ahead and say name my public instance, because it is basically in the public subnet. I'm going to name it as my public instance. Configure the security group. Since we have newly created a VPC, I'll not have any of the existing security groups yet. So the moment I'm going to create a VPC, I am going to have only one default security group that is having all inbound protocols opened up, but only for the same security group itself. As we learned about the security groups in detail during the EC2 section, we learned what is a default security group and what is a custom security group. So I'm going to create my own custom security group here, which is going to be with the SSH, or I'll just give it as web server. Okay, we'll just name it as SSH security group. That will be appropriate. So I'm going to open up the port number 22 for the entire world. And then I'm going to go ahead and launch this EC2 instance. I can use any of the existing key pair which we already have. So I'm going to make use of the Mumbai key pair. I'll just re-verify. Yeah, I have it. So I'll quickly go ahead and say launch instance. So there we go. Our first instance is up and running in a little while. So I'll also create one more EC2 instance, which is going to be a part of this specific side. That is another availability zone. So again, I'm going to select Amazon Linux AMI. I'm going to select instance as T2 micro. And again, we are going to select the AWS training as a VPC. This time I'm going to put it across in the 2.0. Now, if you go and select at 1.0, you'll be able to see that there are only 250 IP addresses available because one instance is currently launched, which has occupied one IP address, right? And I'm going to launch this into the 2.0 because we want to really test whether this has got access to internet or not, and whether this has got access to internet or not, which means the internet gateway and the routing tables, what we have defined, whether they are working really correct or not, we are going to verify it. So I'm going to go ahead and say again, enable the public IP address. Let's see what happens. We of course know that this one doesn't have any route towards the outside world. It is completely isolated, but still I'm going to give it a public IP address to see if it can be accessed from outside the world, or people from the outside world can access this or not. So I'm going to keep the public IP address as enable, and then rest of the options I leave as default. Go down to the add storage. It is going to be of root volume with 8 GB size of type general purpose SSD, and then quickly add the tags. Since we are launching it with the private subnet, so I'm going to keep it as my private instance. And then again, I'm going to attach it to the same security group. Quickly launch with one of the key pair that we already have. Okay, so I just missed to re-explain this diagram yesterday. So yeah, so we created actually this kind of VPC design where we selected a region with the Mumbai, and we created a VPC with the name AWS training, which is a CIDR block range is having this 10.0.0.0/16. We created two subnets. One of them is called as public subnet because we have actually defined a route outside the internet in the route tables. So that's why we call this as a public subnet, and the second one is basically a private subnet. And we have launched two EC2 instances currently, one instance in public subnet, one instance in private subnet, and both of them are secured using the security group. So we are going to learn about the network access control list in very much detail in the next part of our class. So now let's go back and check out these EC2 instances, what's happening with them. So I'm going to go ahead and first pick up my public instance. So I have got the IP address. So I'll just pick up this IP address first, open up my PuTTY terminal. So I'm going to go ahead and give my key pair and then change the size of font. So I'm going to give it a 16 and then OK, and then say open. So there we go. Since it is already in public subnet, we should be able to access directly from internet, and it is responding much faster as normal. And I'm just going to say yes, and then it's going to ask me to log in. I'll just say EC2-user. There we go. I'm able to quickly log in into this. Now, if you see the private IP address, if you remember, each VPC, each EC2 instance, whenever we are going to launch across, it gets a public IP and the private IP. Now, when we create a virtual private cloud, there was a specific range of IP addresses that we have defined. Now, if you see the private IP address of this EC2 instance, it is 10.0.1.134. So let me keep it here. Right, so we created one subnet with the 10.0.1.0 and 10.0.2.0/24. So if you see the IP address here, the 10.0.1 matches with the first part here. So only the 0 has changed and it has become 134. which means, as I said, we are going to get 256 IP addresses in this specific complete range. So I'm going to get few numbers inside this, keeping this as a constant. Now let's learn about this, what happens here. So usually if you see here, there are four numbers, right? So we call them as octets, right? So there are four octets, we call it as, and each octet can move from number 0 to 256. Sorry, it is 255. So totally 256 numbers can be moved across. So it is 0 to 255, right? So each octet can move from 0 to 255. Now here, as I said, specifically we have selected 10.0. So why was it so? So actually we have different types of IP addresses. So I'll just pick up this. So there are different classes, we can say. There is something called as class A, class B, class C, class D, and class E. Yeah, so this is the better one. So here if you see, as I said, that in each octet the numbers can move from 0 to 255, right? So let's first understand this one. As I said, there are four octets: octet 1, octet 2, octet 3, and octet 4, and in each of these I can move from numbers 0 to 255. So this can move from 0 to 255 any number. So currently it is like picked up 192. So again from 0 to 255 I can have a number here. It is shown up as 168. So you can actually go ahead and pick up any number in this specific range of 0 to 255 for each of these octets. Now when we talk about the class A, class B, class C, and class D addresses, what happens in this case? So if you see the first octet, first one, right? So that is limited. So all the class A IP addresses can be between 1 to 126. Now let's go back to Notepad. So if I'm going to select anything between number 1 to 126, that will be defined as a class A IP address. And if I'm going to have anything between 128 to 191, that is going to be a part of class B IP address. And anything from 192 to 223, it is basically class C, and then 224 to 239, it is going to be class D, and finally 240 to 254. Now this is actually set as a standard by the internet companies itself. So they have defined this set of IP address range, which will be used by some set of people. So here it's clearly defined who is going to use what, right? So the class A is specifically used by, yeah, it is reserved for the loop back of the IP addresses. So this is something that we actually use in our real time. Now you might see that sometimes we have IP address of 9 dot something as such, right? So this is something that people across the world start using these IP addresses. And class B is something that is used for, here they have not mentioned it. Class C not mentioned. Yeah, class D is basically used for multicasting, and the class E is basically reserved for the R&D purposes itself. So we cannot use all of the IP address ranges. There are only certain set of IP addresses that is assigned to the companies like Airtel or Vodafone, or even which we call as Hathway, Act. All these broadband companies who are trying to provide the internet are called as ISPs, that is internet service providers. So they have got certain set of IP address ranges limited to them as well, right? So they actually purchase this set of IP addresses, and from that they are going to assign it to us. So that is what that happens up here. So maybe they are part of some class A or class B or class C as well sometimes. Now inside this A, B, C, D, E, and E as well, we have certain set of IP addresses that we can use for the private setup. So if you see in the private setup here, the class A can have anything from 10.0.0.0. So from 1 to 126 range, the range of 10 has been actually set across only for the private IP addresses. So I can go from 10.0.0.0 to 10.255.255.255. As I said, each number in the octet can move from 0 to 255. So I can have up to address range of 255 in this case. Similarly, in the class B, I can make use of a certain set here, that is 172.16. So if you check out the default VPC that AWS has created, that is basically in the 172.31 range, right? Which is nothing but it is part of class B IP addresses. And if you want to go with the class C, you can go anywhere between 192.168 up to 255.255 here from 0 to 0, right? So those are the different private IP addresses that we can actually create. It's not that we can choose to create a VPC of any range. In this case, certain set of IP addresses are reserved for some usage, so we can only create a private IP addresses between these ranges which are available in the class A, class B, and the class C. Now, as I said that each number is going to move between 0 to 255, right? So this is what it actually defines in here. So when I say bar 24 and it says I'm going to get 256 IP addresses, which means the first 3 octets are going to remain constant, that is 10.0.1. And next, as I said, the last octet can move from 0 to 255, and I'm going to get 256 IP addresses, which will be like 10.0.1.0, 10.0.1.1, and dot 2.3, and this will go up to last will be 255. So I can get actually these set of all the IPs in the 10.0.1.0 subnet, right? Since we have given it as bar 24. Now once this number is done at 255, the new subnet can start here with 2.0. So the number will change from this number will change from 1 to 2, and again the combination, again the 2 will have set of 255 IP addresses, right? That is how we are going to define it across. So whenever we are going to give it as bar 24 or bar 20, we have to optimally choose it across. Now if you check out for the default design that Amazon has created, it is with bars. Okay, I come to subnets. So it is with bar 20. Now if you see the subnet first, it has started with 172.31.0.0 bar 20, which has got 4096 IP addresses. So this number, as we know, one octet can only move from 0 to 255. It is 256 numbers can change, right? So here it will be 0.0, then until 16 all the IP addresses are actually reserved until in this itself, right? So here will be the 16.0 and then again bar 20, right? So that is how I get 4096 IP addresses in this case. So any questions here, Rahul? Sure. Okay, so I hope now it is clear why are we using 10.0.0.0 and what does the bar 16 signify, or what does the bar 24 signify. It is basically signifying the size, right? So when I say bar 16, I'm going to get around 65,536 IP addresses. So basically this octet is going to remain constant and I'll be able to move around these 3 octets from 0 to 255. When I say bar 24, it is only that only one of the last octet is going to change across, and then I can play around with it. So now let's get back to our EC2 instances where we have launched through. So I'm here back to my EC2 instances. I'll just go ahead and close this. So I'll just put this into our notepads. So for references, we can use it. Okay, so we were now able to check out that I am able to log in inside the public instance, and that has got a private IP address of 10.0.1.134, right? Since we have selected a VPC of range 10.0.1.0 bar 24, which means the last number can be anything between this 0 to 255, and randomly AWS has assigned me 134 as a private IP address. Let's check out what is the private IP address for the private instance. Yes, it is 10.0.2.243, right? So the first three octets are as per the subnet, and the 243 is the IP address that has been assigned. It has also got a public IP address. Let's see if I'm able to log in from outside the world. Practically, you should not be able to, as per the design that we see in this paint. So let's just check out. I'm going to give SSH auth. So let's see what happens. Are we able to connect to the private subnet or not? So you see, it is giving me network error, connection timed out, right? So however hard I'm going to try, I'll not be able to connect to it, because remember, we have defined this as a private subnet. There is no route defined in order to get inside this subnet, right? From outside the world, no one can get inside to this instance which is in a private subnet. So how do we access it? So we can access this from this instance which is in the public subnet. Now if you see, this is in the same compound, right? So this is 1 acre of land which I purchased. There's just a bifurcation of the availability zones, but if I'm able to enter into this compound and get into the subnet which is public, from here I'll be able to connect to this as well, because they both are in the same compound. Now, so I'll first log in into 10.0.1.0. Here I am already logged in. So from here I'm going to go ahead and log in into the second server. So I'll just go ahead and close this. Now if you remember from one of our previous class on how to log in into a Linux instance from a Linux box. So I'm already inside a Linux EC2 instance. From here, I'm going to log in into another Linux instance. So how do we log in it? So we have the command called as SSH -i. -i is basically the identity. So I need to pass my key pair, and then EC2-user IP address, right? So let's go ahead and first create the key pair inside this. So I already have a key pair. I'll have to check out for the PEM file. I'll edit with Notepad++. I'll copy this key pair. I'll create here. So I'll just say nano Mumbai key pair.pem. So I have got my complete file here, and then I'll quickly go ahead and save this. Control X, Y, and enter. So I have saved this. If I say ls, I'm able to see the Mumbai key pair. So I'll first change the permissions. chmod 400 Mumbai key pair.pem. Now I'm going to go ahead and use this. So I'm going to use the SSH terminal to log in inside the instance. So I'll say SSH -i is basically for identity, and the identity here is Mumbai key pair, and then we are going to log in into the server with the name EC2-user@. Now I don't need to use the public IP address which is assigned to this secondary instance. I just can use the private itself, because we are already inside the same compound. Because we are already inside the same compound, I can use the private IP addresses to identify each other. Now there we go. It says verify your key fingerprint, and I'll say yes. And there we go. You see, I'm already logged inside the 10.0.2.243 EC2 instance. Now if I go ahead and elevate my privileges first, So there I am at a root user. Let's see if I can access internet from here. I'll just say yum update -y. So there you see it is failed. It is unable to connect towards the internet, which means the private subnet setup is completely fine as per the rule. When it is termed as private, it is completely private. So no one from outside the world can access this. Neither the instance can also access the resources from outside the world. So the private subnet setup is completely done as per the design. If you go back to our paint diagram, so if you see, this gateway is attached only towards the public subnet, so anyone from outside the world can access this building, as well as the people from this building can go outside to the world. But people who are inside this building are completely stuck. There is no way out to go. But the people from the public subnet can still access the resources which are there in the private. So they have the access, they can go over inside. Now what I'm going to do is, if people from 2.0 want to go outside to access something internet or as such, so what we are going to do is we are going to set up a bridge, and that bridge is actually called as NAT instance or a NAT gateway. So there are two ways in which you can actually set up a bridge, and that is actually called as NAT. NAT stands for network address translation. Now coming back to one of the introduction part here that we learned yesterday, if you remember, I said that the usually databases will be kept in the private subnet so that no one will have access from outside the world, and the web applications will be kept in the public subnet so that everyone can access it. Now let's say I have installed a database inside one of my instance which is in private subnet. Okay, so this is on, let's say it is on Windows server. I'm just taking a very small example. Let's say I have launched my database on the Windows server. So now currently the Windows is at, let's say Windows XP is the version which is actually going on in this, or Windows server we can say 2000. So let's say Windows server 2000 is actually running on this EC2 instance which is in the private subnet. Now if I want to upgrade this Windows server 2000 to maybe let's say 2012 or maybe the 2016, which is the latest version of the Windows, so how do I go ahead and get it? I need to have access to internet from private subnet. Of course people from outside cannot directly access it, but at least this private subnet should have some way, some alternate way of accessing the internet and get the security updates, patches and other things. So how are we going to do it? That can be actually done using the NAT. NAT basically stands for network address translation. So now we are just going to learn, there are two ways in which we are going to set up the NAT. One is NAT gateway, another is NAT instance. So we are going to learn both the ways of setting up the NAT and check through how the private subnet is going to get access towards the internet. In the meantime, let me again come back to the public instance. So I'll just here say exit, and again I'll just say exit. So first it came out of the root user to EC2FN user, and then we came out of from completely the IP address, that is 10.02.243. We have completely come outside out of it, and now again I'm back to 10.01.134. Now let's check if I'm able to access internet from here. I'll say yum update -y. First I need to elevate my privileges, so I'll just say sudo space so, and then yum update -y. Yes, so I'm able to download the internet packages, everything except from the instance which is in the public subnet. So public subnet doesn't have any problem, so they can go outside, people from outside can access it. Now the problem is with the instance which is in the private. So we are going to help it get access towards the internet, which means only these people from this subnet or this building can go outside, not the outside people can access this. They will not be able to access this because this is completely in private space. But we are somehow trying to enable the access towards the internet for these people by setting up a bridge. So that bridge is actually called as NAT instance or a NAT gateway. Now let's go ahead and get the steps first. I'll just get down the steps. So there we go. I have got the steps here. So the first part of steps is this one. I'll just keep it as like this. And the second part of steps, I'll just go ahead and put it down here. So here we have both of them, the NAT instance and the NAT gateway both. So first we are going to learn the easiest one, that is NAT gateway. So all I have to do is go to the VPC section, then select the NAT gateway category and create a gateway. Let's do it. So I'll go down to the VPC section. So in this, I'll just go down here and see that there's a NAT gateway. I'll click on this and click on the create NAT gateway. So it's going to ask me in which subnet would you like to put. Now, as we know that as per the design, only the subnet which is in the first availability zone has got access towards the internet, or 10.0.1.0/24 is a subnet which has got access towards the internet. So I'm going to go ahead and select that one itself. So here I'm going to select this 10.0.1.0, which is a part of AP South 1A availability zone. So I'm going to create a NAT gateway inside this. So a NAT instance or a NAT gateway will always be created inside this public subnet itself, right? Because these guys have got access towards the internet. So I'm going to create the NAT gateway inside this. So we have selected the subnet. Now it is going to ask me for elastic IP. So EIP is basically a short form for elastic IP. Now elastic IP is basically a concept of having a persistent IP address. If you go down to the EC2 section and scroll down a little down, on the left hand side you will be able to see something called as elastic IP. Now we know that each EC2 instance, whenever we are going to launch, it gets a public IP address and a private IP address. But if I shut down this system and then restart it back, I lose this IP address to something else, right? So initially the IP address is like 35.154.97.70, but maybe I'm going to get something else. So public IP address always changes whenever I shut down the EC2 instance and restart it back. So it is not constant. So how can I keep a constant IP address? I can go down to the elastic IPs. I can say allocate a new IP address. Click on allocate. So this IP address is going to remain constant until I'm going to release this. So is it like 13.127.114.25? So what we can do is we can also attach this IP address to either EC2 instances. So if I click on associate, it gives me here option. I can attach it to any of my EC2 instances which are available, or I can directly attach it to a network interface like the one that we have just created, that is a NAT gateway, right? So I'm going to make use for the NAT gateway. So I'll attach it from the NAT gateway directly. So I'll click on this drop down and click on refresh. So there we go. I'm going to use this elastic IP address to be tagged to this NAT gateway, and then just say NAT, create NAT. So specifically, elastic IPs are a concept of having a persistent IP address. So rather than each time the instances get different public IP address, if you want to have a constant IP address, we basically set it across with the help of EIPs. Now we have attached this EIP to the network interface, that is NAT gateway, for a while. And the next step is, it says in order to use the NAT gateway, you need to ensure that you edit the route tables. Let's check out the steps in my notepad as well. Yes, we are going to the edit the route tables. So let's get down there. So I'll click on edit route tables. So now, as we all know, there are two route tables. One is for internet and one is the main route table. Now in the internet route table, we have explicitly associated one subnet. And if I go to the main route table, you see the 1B 10.202.0, which is in AP South 1B availability zone, is still associated with the main route table itself. So what I'm going to do is, I'm going to set up the bridge across this in itself. So I'm going to click on the main route table, click on the routes, click on edit, and then I'm going to go ahead and say add another route. So here I'm going to say that I should be able to connect to any place in the world, that is 0.0.0.0 bar 0, and this time the target will be, I'm going to use the NAT, not the internet gateway. I'm going to use the NAT. So for the people who are in the 10.0.2.0, which is a private subnet, if they want to access the resources in the internet, they have to use this NAT gateway. So I'll just go ahead and say click save. So there we go. We have successfully able to set up the NAT gateway. So those were the two steps that we had to do. In the NAT instance, we have a lot of steps. The NAT gateways are actually proposed last 1.5 years back when Amazon announced it. So it has become actually easy to set up the NAT gateways. So what did we do? We went to VPC section, we created a NAT gateway, right, and ensure that the NAT gateway is always kept inside the public subnet, and we have created one elastic IP. And we went back to the route tables and edited the main route table, and then gave the destination as 0.0.0.0 bar 0 and tagged it to a NAT gateway. So now let's go back to our EC2 instance. So here I am. I'm going to again make login inside this. So how do we log in? If I just say ls, I'm able to see that I have a key pair. So I'm going to say ssh -i and then the key pair, and then username is ec2-user @ 10.0.2.243 is the IP address. Click enter. It is again going to ask you to verify key fingerprint. I'll say yes, and there we are inside the instance, which is a in private subnet, that is 10.0.2.243. So I'm going to go ahead and elevate my privileges to sudo space su. So now I'm at the root user inside this specific IP address. So now let's go ahead and try yum update -y. So initially we didn't have any access. Now let's check if it has got access towards the internet. Yes, it has got access towards the internet. So I'm able to download the packages and everything else. Now you might also have a question, can we access this using a normal EC2 instance way? Let's check it out. I'm going to again go or copy this public IP address of this one, and again show you that we will not be able to connect from here. So people from outside the world, if they try to connect to this instance, they'll not be able to connect. But the EC2 instance from within will be able to connect to internet and then get all the updates whichever are required to it. You see, it is going to again timeout. Right? So we are unable to connect from outside the world, but from within we are able to connect towards the internet and get the updates. So that was all about the NAT gateways. Yes, few important things here that I would like to explain you. Elastic IPs, yes, they are chargeable only if they are unused. So currently, if you see, this elastic IP is associated to either a network address or maybe the EC2 instance, right? So if you associate with any of the things, then you are not charged for that. But if you just say I want to have a new allocated IP address, and then I'm not going to make use of this, and then if you do not associate it with any of these things, then you are going to be charged, because as we all know, the IP addresses are basically limited in numbers, right? So we don't have unlimited IP addresses. These are some IPs that Amazon Amazon has actually purchased as a internet service provider from the internet standards gateway, whoever is providing it, right? So as we just saw that there are some class A, class B, class C, class D, and class E IP addresses. So out of which only each of these vendors get few IP addresses, and if we are going to waste all the public IP addresses, then it becomes a sheer loss. That's why Amazon makes a charge on this elastic IPs only if you keep it unallocated. So if I am keeping it in used, then there's no problem. Amazon is not going to charge you a rupee as well. But if you just keep it as idle without associating with any of the EC2 instance or any of the network interface, then it is going to charge you for this elastic IP. So I'll just quickly release this. It's okay. So I have one of them now. And second one, the NAT gateways are also chargeable. So currently the NAT gateway which we have created is again chargeable. So if you are going to use it for a longer time, the NAT gateways are chargeable. Now, when we create a NAT instance, it is not chargeable because it is basically a part of free tier. As we all know, as a part of free tier, we get some instances for free, right, for 750 hours per month. So if you are going to launch a NAT instance, that will be free. But if you are going to use NAT gateway, we are going to pay some charges. So currently for the part of doing the lab, you can just do the NAT gateway section for a few minutes to few hours and then shut it down. That should be fine. There should be no problem with it. But in case if you just want to practice the labs more, do it to the NAT instance, which you are going to learn how to set it up in the next class. So any questions here? Rahul, Shiva, from anyone of you? I hope you guys are able to relate what is VPC, what is a public subnet, what is a private subnet. Or am I confusing it with the building analogy? If it is confusing, you guys can let me know, because I feel that that is the easiest way to understand what is called as a VPC, and that makes our understanding much more easier. Tomorrow when we go back to the interviews, if someone asks you any kind of question, you can just think about this analogy and then you will be able to easily get the most of your answers. Okay then, so we'll close the session here itself. Tomorrow we are going to learn how to get the NAT instance and configure it completely. But before that, I would just like to go back and remove this NAT gateway. As I just said, NAT gateways are going to be chargeable. So once you are done with your work, remove the NAT gateway and then also the elastic IP address, because the moment I'm going to delete the NAT gateway, this is going to get unassociated, right? So it will remain idle. So I have to go ahead and release this. So currently I'll have to just check out. Yeah, so it is still associated, but when the NAT gateway will get deleted automatically, this will also get dissociated. You have to wait for a little while. So it will automatically get dissociated, and then I have to go ahead and release this address. So you have got option to here, release the address. And also the EC2 instances, we are done with the work for the day. So I'll just go ahead and close both of them for now. You can keep the VPC. VPC is not chargeable, but whatever resources in this are chargeable, I will keep you updated. So for now, it is only the EC2 instances. As a part of free tier, you can use them, and the charges will be applicable only for the EIPs and the network NAT gateways. So just clean them up once you are done with the part of your lab. Okay, then thanks all. Have a great day, and we'll meet back again tomorrow at the same time to continue the next part of our session on the VPC.